video, we're going to look at understanding the radian measurements on the unit circle. So we can read a unit circle in two different types of angles. We could look at it in the degreed angle, or we could look at it in the radian angle. So what is a radian? What a radian is we're going to have, it's basically taking everything off the word radius. So we are going to have one radius. We've talked about 1 unit, and this is just going to be a rudimentary drawing. But from here, we have, let me fix this just a little bit right there because I want to go from the origin. All right, we're going to have our one terminal ray, and I lied by putting that away. We're going to have a second terminal ray, so they're going to make up 2 terminal rays. All right, so here's my second one. We're basically slicing this pie. All right, and we're also going to slice the pie, and we're going to remove it. So we're going to take this guy right here. The arc length here, this arc length here, is equivalent to 1 radian. Or sorry. Let me go back. The arc length here is 1 radius. So we have 1 r here, we have 1 r here, we have 1 r here. This is a perfectly sectioned piece of pie. When we have that perfectly sectioned piece of pie, the angle that this makes is called a radian. So this angle right here is considered, when it's a 1 radian. All right, and we could keep doing this section of the pie going all the way around. So this is not going to be a perfect drawing. I apologize already. But I'm going to try to eyeball the length that I did here and what the radius looks like. So this is going to be my eyeball length. And then if I draw this right, this is going to be another one here. And then we're just going to stop here at 180. All right, and then again, grab my circle. I'm going to use a slightly different color. I like how I grabbed blue again, as if the circle was not already blue. So there's the second one, and then here's the third one. And then we have this little bit left over here, right here, to make a half a circle. But there are 3 radians, plus this little bit right there that make up half a circle. So an angle measures of 1 radian subtends an arc on the unit circle with the length of 1. Now, if you see, I have 1, 2, 3, and a little bit. So I have 3 point. Let me say that this is this little bit represents 1/4, or 0.1 of another radian, or maybe 0.14 with some trailing marks. And if we notice what 3.14 is, if you remember back to geometry or some other teacher teaching you, we know that this is pi. So from this unit circle, from these radians, from these sectors, we can actually determine that this length in radians from here to here is 3.14 radians, or pi. Which means this top angle right here is pi divided by 2, because if this whole area here is pi, we're going to split that in half to get pi divided by 2. This is 1, 2, 3 pi divided by 2. And then this is just 2 pi. Right, so x and y are divided in the unit circle into 4 congruent arcs, and each representing a pi over 2. All right, so in general, the radian measure, and usually we use x, the book will use theta, of an angle as the length of the intercept arc measure in radian units. So theta, I'll write it out here, is equal to length of intercepted arc divided by radius. So for example, the angle of pi over 2, I'm going to delete all this. The example of, pi over 4, so if this is pi over 2, and pi over 4 would be half of that. We're looking at something here, half. This would be pi over 4. In radians, the intercepted arc is also pi over 4 radians. So this arc right here, that was not too bad. This is also pi over 4 radians. The angle lies in quadrant 1 with the terminal side halfway between 0 and pi over 2. All right, and so with this idea of what a radian is, and how we can use it helps us basically just sketch these things, just knowing where each of these is going to go. So let's say I want to measure 4 pi over 3. I can then come over here and know this is pi over 2, this is pi, and this is 3 pi over 2, and this is 2 pi. All right, so 4 pi over 3 we would see probably 1, 2, 3, divide this into 3, 4 pi over 3 would be 1 unit around and then back through. So the top half of the circle represents pi, and 4 pi over 3 radians is greater than pi, but less than 3 pi over 2. So I just want to make sure I get this angle perfect, well, as perfect as I can in these drawings. So we are looking at it being a little bit closer to 3 pi over 2, because again, just look at 4/3 and 3/2. And so we would look at it being right here in this area, in the 4th quadrant. So the angle of the measure 4 pi over 3 radians lies in 4th quadrant, 3rd quadrant. We could obviously see that as 3rd quadrant, Miss Abney, and has a reference angle of, again, the reference angle is from here, so I would say 4 pi divided by 3, that's a pi, not like a hashtag, minus pi. So pi would be 4 pi over 3 minus 3 pi, minus 3 pi over 3, which would be pi over 3. So my reference angle would be pi over 3. All right. By the way, this is a Greek letter typically used for reference angles. It is a circle, so theta. Sorry, my drawings are going crazy. Theta usually looks like this, phi usually looks like that, and that's what I use for reference angles. All right, so there you go. There is how you can use radians. You use them just exactly like you use degrees. No difference, except now we're kind of throwing in those fractions that you all love and cherish into these equations. Again, guys, if you have any questions or comments, please always feel free to get a hold of me, and I will see you in the next video.